Okay, so in the previous video we are solving practice 4 question 2a. Now I'm going to solve question 2b. It says this is a del operator, okay, and then this is a summation of vector field Q and vector field P, and they're saying that we should prove that this dot product is equal to the dot of Q plus what del P. Okay, so we already know that del is equal to partial ddx of I plus partial ddy of j plus partial ddz of k. Okay, and then the vector field Q is equal to qx of I, that's partial with respect to x of q, plus qy of j, that's partial with respect to y, plus partial with respect to z. Okay, and then p is equal to the same thing, we just repeat it. Okay, so this one crosses individually in another bracket, as you can see, but already we know, it has already been established that I crosses with I to give us 1, and any other kind of combination is 0. The same for the others. Okay, so hence we have divergence on this. Okay, the summation of both vector fields is equal to partial of qx with respect to x, partial of px, that's p with respect to x of x plus p with respect to y, so ddy of q with respect to y plus ddy of p with respect to y plus dz of the q dz, so that's qz, plus d dz, so that's pz. Okay, so you're going to group like terms. You're grouping all the q vector differentials or differentiation. Okay, so we have this so as you can see, I'm doing exactly that. Okay, I'm putting all the q terms into one bracket and all the p terms into one bracket. It has already been established that we can recall that the divergence of a vector field is equal to ddx of ax plus ddy of ay plus ddz of az. Mind you, this ax, a substitute y, a substitute z you are seeing is differentiation. Okay, partial derivative of a with respect to x, partial derivative of a with respect to y, partial derivative of a with respect to z. Okay, so hence we can say from this we can see that this one that divergence of q is equal to partial ddx of qx plus ddy of qy plus ddz of qz, and then divergence of p, vector p, ddx of px plus ddy of py plus ddz of pz. Therefore this is equal to divergence of q, vector field q, plus divergence of vector field p, hence proved. Okay, so basically that is it. If you have any suggestions or any problems, just leave your comment or question in the comment section. Okay, thank you so much.
If you remember, at a point in the video, Okopa said the dot product of I and I is 1. Let me emphasize on this. This is because the alphabets I and J are just representing unit vectors for our proof. Because they are unit vectors, the magnitude of I is equal to 1 and the magnitude of J is also equal to 1. Now we know from our scalar dot product formula that some vector I dot some other vector J is equal to the magnitude of I times the magnitude of J times the cosine of the angle between them. Let theta represent the angle between them in this specific situation. Now, if the angle between them is 0, which means theta equals 0, we are going to have this result, which implies cosine of 0. But cosine of 0 is 1. Therefore, the magnitude of I, which is 1, times that of J, which is 1, times the cosine of 0, which is 1, is going to give us a dot product of 1. But if the angle between I and J is 90, then we are going to have cosine of 90 over here. And we all know that the cosine of 90 is 0. Therefore, the dot product of any two different vectors from the I, J, and K space is 0. But when the vector dot itself, we are going to have 1 in a particular instance because we said I, J, and K are all equal to 1.